Hello friends, welcome to Risingpearl.com. Today we are talking about series 3 where we are learning about trigonometry. This is webisode 7 and today's topic, friends, is solving problems related to trigonometric ratios of an angle. This is part 3. Part 1 and part 2 were webisode 5 and 6 respectively. So we are going to continue to find out what kind of questions we may be getting on this topic and how we solve them. So like we have been doing before, friends, every opportunity that we get, we want to reinforce the trigonometric ratio of an angle. So if I have a right triangle ABC with angle B assuming 90 degrees and angle A and angle C are the two acute angles. So for angle A I can write the sixth trigonometric ratio in this fashion. So sine A is equal to opposite side BC divided by AC. Let's write it probably over here. So the sine for sine A it will be BC divided by AC. Similarly, cos A will be AB, adjacent side, AB divided by AC, which is the hypotenuse. For tan A, it will be the opposite side, BC, divided by adjacent side, AB. Now for cosec A, we know it is the reciprocal of sine A, so that will be AC by BC. AC by BC. Similarly, sec A is reciprocal of cos A, so it should be AC by AB. It should be AC by AB. Now, for cot A, that is reciprocal of tan A, so it will be AB by BC. AB by BC. So friends, also we have learned that like in algebra, we use the lower letter x to denote unknown quantity or unknown amount or anything unknown variable. Similarly, if we do not know any angle in a trigonometry, it is common practice to represent them by theta. So theta is expressed as this symbol and it is actually spelled theta, Theta. So you may see that sec theta or tan theta or cos theta or something of that sort is given. So what it means is it is just theta is an angle that the question is referring to. Now friends, we have also seen in the earlier two episodes that one of the type of very common question format is one trigonometric ratio is given and then find out what are the other trigonometric ratios of the same angle. How do we solve these questions? Well, first we find out if one trigonometric ratio is given, it really means the two sides of a right triangle are given to us. Then if two sides of a right triangle they are given to us, then applying Pythagoras theorem we can find the third side. The moment we find three sides or the third side of a right triangle, then we can find out all the trigonometric ratios in that right triangle. So now friends, let's go back, and in the last webisode question 3 had two parts, A and B, or 1 and 2. Because the video was becoming so long, so we paused it and we ended that video actually. So here we are going to take a look at the part 2 of question 3. So in a triangle ABC, right angled at B, so we have drawn a triangle ABC and it is given specifically that right angle is at B, so we have to keep in mind when we draw a triangle. If tan A is equal to 1 by square root 3, find this relationship. So like we always do, first we have to find out the three sides. That way we will know what each of these ratios mean, right? So what do we know here? If this is my angle A, right? So tan A, so what is given is tan A is equal to 1 by square root 3. It's 1 divided by square root 3. But we also know that tan A, what is tan A in terms of the ratios? Tan A is BC divided by AB. So if this ratio is 1 by square root 3, then I can say that from here we can imply that BC can be, let us say, any value, let us call it x. The length BC can be x, then AB can be square root 3 times x. Why? Because the ratio of BC by AB is 1 by square root 3, so I can have x by square root 3x. And why we will not use BC equal to 1 and AB equal to square root 3? Friends, this we have repeatedly discussed in the last two webisodes. It is the ratio which is given. We have not been given the exact dimensions, right? So now, if in my right triangle ABC, if BC I know and AB I know, then I can find AC using Pythagoras theorem. So Pythagoras theorem states, let's write it here to give ourselves a little bit more space. AC square, hypotenuse square, is equal to the square sum of other two sides square, right? So BC square is x, so it will be x square plus AB square, and AB is square root 3. So this, or in other words, x square is actually x square. Square root 3 times square root 3 is 3, and 3x square. Why? Because square root 3 times square root 3 is equal to 3, right? So this will be actually 4x square. This should be 4x square. Let's just say 4x square. So if AC is equal to 4x square, from here it implies AC is equal to 2x. If you do square root on both sides, you will get AC equals to 2x. So AC, this length is 2x, right? So at this point, friends, what we can do, we can now find out the value of each of these ratios. And we can simply plug the value of each of these ratios in this expression, and we can find out the value of this expression. So here, let's clean this up a little bit. So what we have is, so this is 2x, this is x, and this is square root 3x. So let us write the values here, and then we are going to fill it in, right? So this expression is equal to, let's find out cos A. So one thing important to understand, friends, is that I have got two angles involved, angle A and angle C. So we have to pay attention. It is not all the same angle. There are two separate angles involved. So cos A is how much? Let's write these four values here. So cos A, so this is my angle A. So cos A is adjacent side divided by hypotenuse. So it will be square root 3 by square root 2. X and x will cancel out. I mean, we can write like this. And then x and x will cancel out. So this will be square root 3 by 2. So we have found cos A. What about cos C? For cos C, so this is C. This angle is C. So cos C will be adjacent side x divided by hypotenuse. It will be x by 2x or 1 by 2. So this is 1 by 2. So what about sine A? Let's write sine A here. Sine A will be equal to, this is sine A. Sine, this is A. A will be opposite side by hypotenuse. It will be 1 by 2. And then sine C is the last one. Sine C. For sine C, for this is C, it will be opposite side by hypotenuse. It will be root 3 by 2. Square root 3 by 2. So now let's put all these values. We need four values, and we found what these values are. Let's just put these values in here. So cos A is root 3 by 2. Root 3 by 2 multiply by cos C. Cos C is 1 by 2. 1 by 2. So this is the first product minus, I have got sine A is 1 by 2 times sine C is root 3 by 2. root 3 by 2. So this one is root 3 times 1 is square root 3. 2 times 2 is 4. So square root 3 by 4 minus 1 times square root 3 square root 3 by 2 times 2 is 4. So essentially, friends, it is the same number. So this minus this is basically 0. So the value of this expression is 0. So friends, this is how we solve questions. I think we, between our webisode 5, 6 and 7, we have covered lots of different types of questions that typically you may see on questions related to trigonometric ratios of angles and how we solve these questions.